Here we have another u-substitution example problem, and this example problem can be a little bit tricky if we're not used to splitting up our integrals. So what we have here is 10x plus 3 over x squared plus 16, and the first step is we want to split up our integral. So we'll take our numerator of 10x plus 3 and we'll split that up into 10x and 3, and we'll keep our denominator the same. And so now we have two separate integrals that we can solve individually in order to get our solution. So we'll go ahead and solve the left-hand side. And the first step is we can go ahead and factor out this 10. And so now we're left with an integral that we're used to seeing. We can go ahead and apply our u-substitution technique and get u is equal to x squared plus 16, and our du will equal 2x dx, or 1/2 du is going to be equal to x dx. And so the last step is we can go ahead and input our u and du terms into the original integral, and we'll go ahead and solve. And so we know that this 1 over u du is just the natural logarithm of u, and so we'll go ahead and do that and get our solution for the first integral. Now we can go ahead and look at the second integral, and the first step in evaluating this integral is we can kind of recognize that the denominator looks like an inverse tangent function, or the integral for an inverse tangent. And so we can go ahead and factor out this 3, and what we're left with is 1 over x squared plus 16. And so the question we should ask ourselves is, how do I get this x squared plus 16 to look like x squared plus 1? And one way to do that is by dividing 16 throughout all three terms, the 3, the x squared, and the 16. And so we'll go ahead and do that, and what we're left with is 1 over x squared divided by 16 plus 1. And so the next step is, how do I get this x squared over 16 to look like just a variable? And so we can go ahead and recognize that this x squared over 16 is really just x over 4 squared. And so now we have it in a similar format, and we can go ahead and do some u substitution. So our u will be equal to x over 4, and our du will be equal to 1/4 dx, or 4 du. And so now we can just back substitute our u and du into our integral, and it looks very similar or identical to our inverse tangent of x. And so we can go ahead and apply that and then back substitute our u to get the solution for our right hand side. And then by combining these two solutions, we'll get the solution to our example problem.